So hello everyone, welcome back to my YouTube channel. In the previous module, we discussed about how data is stored, how variables are stored, then what is a data type, how we can take input and how we can show the output in Python. In today's video, we are going to focus on operators and expressions in Python. So let's get started. We will first see what actually operator means and what is expression. So basically, an operator is a special symbol that performs an operation on one or more operands. Yes, so examples may be addition, subtraction, multiplication, division, modulo division, power, and so on. There are many examples of operator. So basically, this is nothing but a symbol which will perform operation on operands. So here, if I perform 10 plus 3, so 10 and 3 are my operands, or A and B are my operands, and this plus is nothing but an operator. Similarly, what is expression? Expression is a combination of operands, that is values, variables, etc., and operators that evaluates to a result. Example, A plus B, x into 5 minus 2, a plus b divided by c. So here we make use of combination of operands and operators. Then it becomes an expression basically. Okay. So I hope you understood what is the simple meaning of operator and expression. So first we will see about the arithmetic operators. So what are the different arithmetic operators we have basically? So we have addition, we have subtraction, we have multiplication, we have division, we have floor division, modulus, exponent. So these are the major arithmetic operators. Now we'll see with the help of example in the Jupyter notebook and I'll try to explain you all these particular arithmetic operators. So first thing that we are learning today is about arithmetic operators. Okay. So if I write here a equals to 10, b equals to 3. So these are my two variables basically. A is pointing to the object 10, B is pointing to the object 3. Okay. If I write here print A plus B, so I will get the output as 30. Similarly, if I write here print A minus B, then I'm writing print A multiplied by B, print A division divided by B, then print A floor division B, then print A modulo division B, and then print A raised to B. So these are the arithmetic operators that I have. If I execute this particular command, now we'll see what is the working behind it. So this addition, 10 plus 3, 13, 10 minus 3, 7, 10 into 3, 30. So these three things are clear. These are the basic operations. Okay. Now, basically A divided by B, that is 10 divided by 3. It is nothing but 3.333. This is nothing but it is giving me the output as a float. It is always a float. So basically, this is nothing but always float. Okay. Now here, A floor division B. A floor division B, this is giving me output 3. This is nothing but the quotient. This is nothing but a quotient integer. This is always an integer quotient. It is a quotient and it is an integer. And A modulo divided by B. This is giving me output 1. 3 3s are 9. Then there's a remainder is 1. So basically modulo is giving me nothing but a remainder. This is nothing but my remainder. So these are the three variations we have in division. If I write A divided by B, it will give the result which is always a float value. Then if I write A floor division B, it will give me the quotient which is an integer value. And if I write print A modulo divided by B, then it will give me the remainder. So I hope you understood the difference between this. And then A star star B is nothing but A raised to B, that is 10 raised to 3. So it is nothing but 10 raised to 3. That is giving me the output as 1000. Okay. Okay. Now we'll just see one more example related to division. We'll deep dive into this particular thing. So let us understand the difference between division versus floor division. Okay. So if I write something like this, print 10 divided by 2. So this will always give me the output in float. So here the answer is 5, but the output will be 5.0 basically. It is in float. Okay. If I write like this, print 7 divided by 2. Here I will get 3.5. Okay. Similarly, I will perform now floor division. If I write print 7 floor divided by 2, floor division by 2. So it will provide me the quotient, that is 2 3s are 6. So it will provide me only 3. Okay. Then now comes the interesting part. If I write here something like this, minus 4 floor divided by 2, minus 7, sorry, minus 7 floor divided by 2. So the what output it is providing me? It is providing me the minus 4. So basically what things you have to remember here it is. If it is 3.5, then its floor is nothing but 3. But if it is a negative number, let's say minus 3.5, its floor is nothing but minus. The floor is minus. If it is a negative number, its floor is, if it is minus 3.5, floor value is minus 4. If it is 3.5, that is positive number, its floor value is 3. Okay. And it is not minus 3 basically. This thing you have to remember basically. Okay. So I have you understood this. What if I want to prove this particular thing? So there is one library which I can import here, import math, and we can write here print math dot floor, floor of 3.5. And similarly, if I write here math dot floor of minus 3.5. So you can see here it is giving me 3 and minus 4. Now let us understand more about modular division. Okay, modulus. Modulus. So if I print something like this, print 10 modulo divided by 3. It is nothing but giving me remainder as 1. So basically modulus gives me remainder. If I print like this, 8 modulo divided by 2, it is divisible by 2. It means remainder is 0. Remainder is 0. Okay. Now, where we make use of this particular modulus. So I will give a practical example basically. Practical example. So let's say I want to know whether a particular number is even number or odd number. So how I can write here? If my particular number is, let's say 17, the particular number is 17. If I write like this, 17 modulo divided by 2, it is going to give me remainder as 1. Basically, it is not an odd number. If I write in print any even number, 18 modulo divided by 2, it is going to give the remainder as 0. So if I execute it, I'm getting print 18 modulo divided by 2, remainder as 0. So basically, if it is an even number, the remainder is 0. If it is an odd number, the remainder is not equal to 0. Correct? So for that, how I can write a program basically? Let's say n equal to 23. If my n modulo divided by 2 equal to 0, okay, then print f string n is even number. Correct? If that is not the case, else print f string n is odd number. So this is the basic example. Okay, so 23 is odd number. If I write here 104, execute 104 is an even number. So I hope you understood what is the practical usage of modulus. There are many other uses also. We can use as a cycle through indices, that is wrapping. Then we can use very most important usage is the extraction of digits. Let's try to execute that. Extract digits. So let's say my number is n is equal to 1, 2, 3, 4, 5. I want to extract the last digit. So last digit I want to extract. So I can write something like this. Last digit is equals to n modulo divided by 10. If I modulo divided by 10, this particular number, if I divide by 10, what is the quotient? Quotient is 1, 2, 3, 4, and a remainder is 5. So I will get a remainder. So remainder is nothing but my last digit. So this will give me the last digit. If I write here like this and print the last digit, then I will get 5. Similarly, if I want second last digit, first let us understand what we get if we write something like this. N floor divided by 10. If I execute this, I'm getting 1, 2, 3, 4. This correct? So this is nothing but my quotient 1, 2, 3, 4. So if I write like this, n floor divided by 10, I'm getting 1, 2, 3, 4, and I want second last digit, that is 4. From this result, then I will do modulo divided by 10, then I will get the digit as last digit, that is 4. So basically for second last digit, what I can write here is second last is equal to n floor divided by 10, and that result modulo divided by 10. And then I will print second last. and we'll get the answer as 4. 5. 5 is the last digit and second last digit is the 4. So I hope you understood how we extract digit using floor division and modulo division. Okay. What if we do negative number modulo? So if we divide, if you do negative number floor division, you get something output. If it's a positive number, it is output is like this. If it is a negative number, the floor is something like this. So what if we perform -7 modulo divided by 2? If I execute, I'm going to get answer as -1. Sorry, +1. Similarly, if I'm going to write print 7 modulo divided by -3, I'm going to get -2. Similarly, if I'm going to write -7 modulo divided by, let's say 3, I'm getting the answer as 2. So what difference you can see here? What is difference? The difference is the result always has sign of divisor display in Python. Okay, so here my divisor is 2. So the sign of 2 is positive. That's why the answer is +1. Here the divisor is -3. Sign is negative. So my answer is negative. Here I have wrote -7, but still the sign is +2 because the divisor sign is +3 or positive. Sign is positive. So this thing you have to keep in mind. The result always has sign of the divisor in Python in modulo division. Okay. Now let us understand about exponents. Okay. So if I write something like this, print 2 raised to 10, what I'm going to get is 1024. Similarly, if I write print 10 raised to 0, that is anything raised to 0 is 1, correct? Now what if I want to perform square root? Square root. Square root is nothing but anything raised to half or 0.5. So if I want a square root of 25, I can write print 25 raised to 1 by 2, that is 0.5. 25 raised to, so square root, should be comment, okay, 5, and it is given me the answer as float value 5.0. I similarly write like this. I want to cube root. Let's say cube root of 8. So 8 raised to, cube root is nothing but 1 divided by 3. Yes, I will get 2. I hope you understood about the operators. Okay. Now how I can use these arithmetic operators in strings? So arithmetic with strings. Basically, the first application is concatenation. How can I concatenate the strings? Basically using the plus operator. So if I write something like this, print, hello, this is my first string, plus second string is space, and the third string is world. So if I execute this, print, if I execute, okay, wait. If I execute this, I will get hello world. So basically, these three strings are concatenated using the operator plus. Similarly, second application can be repetition. Let's say I want to repeat this particular string star 100 times or 5 times, 50 times. So I can write like this into 50. I will get 50 times that particular character. Like this you can do for a word, character, letters, anything. Okay. Okay. Now let's say third application, what we can here is plus on lists. That is equal to nothing but merge. Basically, I want to merge two lists. So print 1, comma 2, this is my first list, plus 3, comma 4, this is my second list. If I execute, I will get a merged list 1, 2, 3, 4. Okay. Similarly, fourth application, star on lists, that is equal to repeat the list. So let's say print, this is my list 0. I want to repeat it 5 times. So if I print this, I will get an element 0 5 times in a particular case, 0, 0, 0, 0. If I write here 0, comma 1, comma 3 and do like this. So 0, 1, 3, 0, 1, 3, 0, 1, 3, 0, 1, 3, 5 times it will get repeated. So I hope you understood how we use arithmetic operators in strings and lists. Okay. Okay. Now what are the different errors you can get? Errors. Basically, if I write something like this, print. This is my string 5 plus 5. So what I'm going to do is I am concatenating basically a string and an integer. So this is an error. That's a type error. So we can only concatenate a string to a string and not to other data types, int, float, etc. So this is one type error. Okay. Then one more error, that is nothing but zero division error. Zero division error. What do you mean by zero division error? If I divide by zero, it is answer is infinity. So 10 divided by zero, we cannot divide by zero. Division by zero is not. So zero division error. Similarly, if I write something like 10 modulo divided by zero, again same zero division error. Okay. So we have covered the arithmetic operators. The next operator is nothing but an assignment operators. What are the different assignment operators? Equal to, plus equal to, minus equal to, star equal to, divide equal to, floor division equal to. What is the use of these particular operators, assignment operators? We'll see with the help of examples. So the next thing we are going to study is about assignment operators. Okay. So let's say x is equal to 10. I'm going to print type of x, type of x, comma, x. What I'm going to get is it is of type integer and 10. Correct? Now what I'm going to do is x, I'm going to use the next assignment operator, that is plus equal to 5. Now this assignment operator is nothing but equivalent to writing x equal to x plus 5. Basically, I'm incrementing x with 5. So my x original value is 10. 10 plus 5, 15. Now the new value of x will become 15. So this, in shortcut, we can write like this, x plus equal to 5. There is nothing but x equal to x plus 5. Now similarly, if I write here print type of x here, comma x, then what I'm going to get the result is integer and the value is 15. Similarly, x minus equal to 3, let's say. So it will so it will subtract 3 from the original x value, that is 15. 15 minus 3 is nothing but 12. So I will get the answer here as 12. So let's say print x, getting the answer as 12. And type of x is nothing but int. Okay. Next assignment operator is nothing but x star equal to 2. That is nothing but multiply the original value of x by 2. And this is going to be 12 into 2, that is 24. So new value will become 24. So if I write here print type of x, comma x, I'm going to get is 24. Okay. Now, x divide by equal to 4. Print type of x, comma x. Now what this particular thing will do? 24 will be divided by 4. That is nothing but 6. Correct? But if I try to print the type, now this will become the float. Now it will convert the type to float basically. Okay. Similarly, if I write like this, x floor division equal to 2, it will give me the quotient basically. So my value is 6. 6 divided by 2, the quotient is 3. So I will get the answer as 3. So type of x, comma x. You will get float and 3. Okay. Similarly, x modulo divided by equal to 2. So here the 3 will get divided by 2 and the remainder is 1. And remainder is 1. So I'm going to get the remainder as 1. So print type of x, comma x. So here the remainder is 1. Type of x is float. Similarly, x raised to 4, raised to equal to 4, like this. So this is nothing but x, the whole raised to 4 will be my new value. So my x value is now 1. 1 raised to 4 is nothing but 1 only. So if I try to print it, print type of x, comma x, I will get float and answer is 1. Correct? Yes. Now, this particular thing also works on strings and list. Let us see. S is equal to, let's say, one string hello. Now I'm going to write S plus equal to space world. Okay. Now if I try to print S, I will get hello world. Basically what it is doing, concatenating the string. So string is hello. S is equal to, this is nothing but S is equal to S plus world. So this is nothing but string concatenation. My S is itself a string and world is also a string. And here I'm using the plus operator that is nothing but concatenation. Correct? So this works on concatenation of strings also. Similarly, if I have a list, let's say list is 1, comma 2. And in the same list, I'm modifying it like this list plus equal to, let's say 3, comma 4. And if I print the list here now, I will get, sorry, last one list, I will get 1, 2, 3, 4. Okay, I hope you understood about the assignment operators. Okay. Now the next thing is nothing but a comparison operators. What are the different comparison operators we have? So let's see here. So we have equal to, not equal to, greater than, less than, greater than or equal to, less than or equal. So everyone must be knowing these comparison operators. We'll try to understand this with the help of the examples. Let's say A equal to 10 and B equal to 20. And I want to compare the two values basically. So comparison operators are used to compare the values. So if I write print A equal to B, it will compare whether A is equal to B or not. It is not, then it will give me false. Print A is not equal to B. Print A is greater than B. Print A is less than B. Correct? So what I'm going to get output false, true, A is greater than B, false, B is greater than A, true. Okay. And so on for greater than equal to, less than equal to also. So can we compare strings? Can we compare strings basically? Comparing strings. Okay. Yes, we can compare string, but as I said, it will compare the values. So what are the values in string? It is nothing but it will see the alphabetical or you can say lexicographical order. Okay. It is nothing but based on the ASCII characters. So if I write print apple equal to banana, are they equal? No, it will give me false. If I write print apple equal to apple, are they equal? Yes, so it will give me true. Similarly, if I write something like this, print z is less than a, is less than character a, so it will give me false. Because why it will give me false? Because the ASCII value of z is greater than a. But if I write something like this, capital Z is less than a, then it will give me true. Why? The reason is when we write capital Z, its ASCII value is 90. And if I write lowercase a, its ASCII value is 97. So 90 is less than 97, correct. So it will give me a true. Now let's say I want to compare different types. Okay. So let's say print 1 equal to 1.0. Now this 1 is integer and 1.0 is float. Correct? It is giving me true. Print 1 equal to boolean true. Boolean true is nothing but 1 only. It will give me true only. Print 0 equal to false. Boolean false is nothing but 0. So it will give me true. Similarly, if I write print 5 equal to string 5. Can you compare this? Can you compare this? No, false. It is giving me false. Why it is going to give me false? Basically, the reason is int is not equal to string and there is no auto conversion basically. There is no auto conversion. If I write something like this, convert this, I'm explicitly converting, type converting it, this particular string into int. Now if I run this, then it will give me true. Okay. So I hope you understood how comparison operator works. Now let us try to understand something called as chain comparison. Chain comparison. What is this chain comparison? Let's say x is equal to 15 and I'm printing here 10 less than x less than 20. So is my value greater than 10 and less than 20? Yes, so it will be print me true. Basically, it will check these two conditions. X is greater than 10, x is less than 20. Like this. If I'm writing something like this, print 1 less than 2 less than 0, basically it is going greater than 0. So true. It will check whether 2 is less than 1 or 2 is greater than 0 like this. I'm writing something like this. Now in this case, 2 is greater than 1, but 0 is not greater than 2, or 2 is not less than 0. So it will give me false. So this is nothing but a chain comparison. Now what is the real world use case of this? Let's say age is equal to 25. So I am going to compare if 18 is less than equal to age, less than equal to 60. Okay. Then print it is a working age. Basically, I'm comparing that particular age is between this greater than equal to 18 or less than equal to 60. Then that particular age is working age. Like this. So it is a working age. If I write here 13, I will not get any output because I have not given any condition for that. If the age is between this, then it is a working age. Only this, it will print. Okay. So this is the use case of the chain comparison. Basically. Let us move towards the logical operators. So what are the different logical operators we have? In logical operators, we have and, or, not. So this is basically a truth table for and, or, and not. So true, 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 false, 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 true, false, 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 false. And if it is a or, anyone is true, then it is a true. Both are false, then false. And not is basically the opposite. Let us try to understand logical operators with examples. Now we'll cover the logical operators. Let's say x is equals to true and y is equals to false. Okay, these are my two variables, true and false. So if I print basically x and y, then I will print x or y. Then I will print not x, print not y. Okay, print TRINT. Okay, then I'm going to get true false is false, true or false true, negation of true is false, and negation of false is. These are the basic logical operators. Okay. Now, what is the real world conditions where we can use this particular thing? Let's see. Age is equals to 25. Has ID equals to true. Then let's say is VIP is equals to false. And I'm going to use an AND operator basically. AND means all must be true. So if age is greater than equal to 18 and has ID, basically, then what I can write print entry is allowed. Entry is allowed like this. So here what it will check whether my age is greater than equal to 18 and it has a ID. Basically, has ID should be true. So true, true. We both are true, then this particular statement will get executed. Entry is allowed. Correct? Similarly, for or, what I can write? For or, at least one should be true. So if I write if age is greater than equal to 18 or is VIP, then print entries allowed. Correct? And similarly for not, we're just going to flip the value. If it is true, it is false. If it is false, then it will be true. So is banned is equals to false. Okay. Then if not is banned, if not is banned, then we have to go into write print welcome. So how this program will work basically? If I combine all this together, we combine all this together, it will be if age greater than equal to 18 and has ID and is not is banned. Not is and not is banned. Then we can write here print full access granted, something like this. So execute this particular command code. So what I'm going to get age is 25 and ID is true. So entry allowed. Similarly, age is greater than 18 equal to 18. So this means it is true. So entry allowed. Anyone should be true. VIP is false, but this is true. So it is entry allowed. Now is band is false, but if I do not is band, this means it will become true. So it is welcome. So this is true and this is true and this is also true. So full access band. So I hope you understood about the logical operators. Let us try to understand about short circuit evaluation. What do you mean by short circuit evaluation? If I write something like this, false and print hello, what is going to be printed? This is AND logical operator I'm used. For AND, both should be true. So false and print hello, it will print false only because this is false. This is false, so it will print false because for AND to be true, both should be true. Similarly, if I write like this, true and print hello, it will print hello now. Why? Why it will print hello? Because this is true and this is also true. So it will print hello. Now how it is working actually? What is the short circuit evaluation basically? Okay. So for the first statement, false and print hello. Print will never run. Print will never run. Why? Because we have used logical operator and if my first statement or the first condition is itself false, then it will not see the next condition only. Print will never run. And in this case, it will print hello. So it will print will run. Print runs. Because my first condition is true, so it will check the second condition also. So let us check for or. So if I write true or print hello. So for or any one condition should be true, then it is true. So it will check here true. So then it will not check for the print. It will directly print true. So it will not print hello. So in this case, print never runs. Similarly, if I write here false or print hello. So in this case, it will check first false. It is not true. And it will check the print statement also. Print hello. Then it will print hello. So here basically print will run. Print runs. I will get hello here. So I have you understood about the short circuit evaluation. Now what is the practical usage of this? Practical usage of this. So let's say my x value is equal to 0 and I'm writing if 100 divided by x is greater than 5. Okay. And so on my statement is there. But here x value is 0. If I write 100 divided by 0, my program will crash because it is getting divided by 0. It is getting divided by 0. So what I can write here? So instead of this particular thing, what I can write, if x not equal to 0 and 100 divided by x is greater than 5, then print large. Something like this. Else print x is 0 or result is small. Something like this. So what this particular command will do basically, now my code will not crash. Basically, if my x is 0, first it will check x not equal to 0. My x is 0. That means this particular statement is false. So in any AND logical operator, if my statement is false, that means my whole result is false. So it will not check the further conditions. It will directly print else x is 0 and result is 0. Okay, x is 0 and result is 0. So in this way, my program will not crash. If I don't write like this, if I write it like this, I'm not providing this particular condition, if x and so on. Okay, and what I'm going to get? Program will crash because there is a zero division error. Okay, so I hope you understood about a short circuit evaluation and what is the practical usage of that. Now, logical operators also returns values. So if I write this print 1 and 2, and I'm writing like this print 0 and 2. What is the output I'm getting? 2 and 0. Now, what is the meaning of this output? Why I'm getting this output? So when logical operator return values, basically. Okay. So basically talking about the AND, it returns first falsy value or last truthy value. If all are truthy, or last truthy value if all truthy. Now, in the previous video, we already discussed about what is a truthy value and falsy value. So in this case, one is truthy value, two is also truthy value. So both are truthy value. That means all are truthy value. Then it will return me last truthy value, that is 2. In this case, 0 is falsy value and 2 is truthy value. In this case, it will return me the first falsy value, that is 0. This is the case for AND. Similarly for OR. Similarly for OR, it will return first truthy value or the last falsy value if all are false. Basically, if I write print 1 or 2, I will get the first truthy value, that is 1. If I write print 0 or 2, here I will get the first truthy value, that is 2. Correct? Now, if I write both falsy, that is 0 or empty string also a falsy value. So it will give me the last falsy value, that is the empty string. Similarly, if I write print 0 or empty string or an empty list, basically it will give me an empty list because that is the last falsy value. Okay. Now, what is a practical usage? Practical example, we'll see about this practical example. Let's say user input. User input is an empty string basically. The user has provided an input that is empty string. Okay. But I want some value. So value is equal to user input or I can write here default. Now basically this user input is nothing but falsy value, that is empty string. And this is nothing but the truthy value, that is a particular, I'm giving a value to a string. Default is my string. So falsy or truthy, and I'm using OR operator. That means it will return me the first truthy value. That means if I print here value, it will give me default. It will give me default. So this is a practical example of this particular concept. Okay. Now the next part is about the membership operator. Membership operators. What are the different membership operators? In, not in. Basically, why we use in? If you want to find if a value exists in a particular string or list or tuple or dictionary and so on. So if I write something like this, name is equals to Python programming. This is my string, name is my string. If I write print Python in name, so this will basically give me the output in true or false. So it is true, Python is present in this particular string. Yes. Similarly, if I write print Java in name, Java is not there, so it will give me false. So this is for string. Similarly, we can have it for list also. In list, let's say I'm writing fruits is equals to apple, grapes, banana. Okay, these are my list. This is my list. Now I'm going to print whether apple in fruits. So I'm getting true. Okay. This can be useful in tuples also. I'm writing a tuple, let's say primes 2, 3, 5, 7, 11. So I'm writing a print 4 in primes. I will get false. Okay. In sets, if you want to use this, let's say set is equals to admin, comma, editor, comma, let's say viewer. Role is equals to admin. Okay. And I'm writing print role in set. Basically, it will give me true because this role is nothing but admin. If I directly write this print editor in set, then also it will give me true. Okay. Then what is the next? Later I have dictionary. If I write dictionary something like this, person is equals to name. This is my key and value is Alice, comma, second key is age, value is let's say 25. So this is my particular dictionary. If I try to print name in person, I will get true. Okay. So this is how we can use in operator. And what about the not in operator? If I try to print here, print email, not in person. So email is not there. I know that will also give me true. Correct? If I write an instead of email, A is not in person, it will give me false. So I hope you understood about the in operator and the not in operator. These are nothing but membership operators. Okay. Next operator is identity operator. Identity operators, where we use identity operators. So identity operator check if the two variables point to same object in memory or not. That is same object in memory. We have already discussed in our previous video also about this. Let's say, let's say A is equal to one list 1, 2, 3, B is equals to A, and C is equals to 1, 2, 3. Okay. Now here if I write print A equal to C, what I'm going to get? True. Why I'm going to get true? Because here they are nothing but same values. They have same values. But if I write print A is C, I'm going to get false. Why? Because A is pointing to a different object of list 1, 2, 3, and C is pointing to a different object. So basically, is operator tells us about whether the objects they are pointing is same or not. So here, different objects basically in memory. So let's print the IDs also. Print the ID of A, comma the ID of C. You will get that they are different IDs, different IDs. That means they are pointing to different objects. Their value is same, but they are pointing to different objects. So this is the use of each keyword. Okay. Similarly, if I write here print A equal to B, here also I will get true because I'm assigning that particular variable B equal to A. So A is assigned to B. Now here if I write like this, print A is B, I'm getting true. True means pointing to same object. Pointing to same object. Okay. That means A and B are now pointing to same object 1, 2, 3. But C is not pointing to that object which is pointed by A and B. C is pointing to a different object. Let us try to understand this. Let us print the ID of A, ID of B, as well as the ID of C. So you will see that the ID of A and ID of B are the same, but the ID of C is different, even though the value of all the three are same. In the previous video, we already discussed about the integer catching also. How Python catches the values that are ranges from -5 to 256. If you haven't watched the previous video, do watch it. The link is in description. So next concept is bitwise operator, the most important operators. So basically in bitwise operator, we have AND, OR, XOR, NOT, left shift and right shift. Okay. Now how this particular thing works. Basically, if I provide A equal to 10, B equal to 4, it works on a binary numbers. Okay. So this bitwise operator works on the binary or bits. So A and B, here it will work bit by bit. So 0 and 0, 1 and 0, 0 and 1, 1 and 0 like this. So whatever is the result, we'll get the result in binary. Again, or XOR, not, left shift, right shift. All things will work on bit by bit. Okay. Let us try to understand this with the help of examples in the Jupyter notebook. So we are starting now bitwise operators. Okay. So first, let us try to understand what is this binary numbers. So if I write binary of 10, so it will give me 1010. This 0b is nothing but a binary representation, basically code. 1010 is the binary representation of 10. Similarly, if I write binary of 15, so I will get 1111. Apart from binary, if you want hexadecimal or octal, you can write print x of, let's say, 256. I will get 100. Or print, I want octal numbers, I will write oct of 8. So I will get 106. Okay. Now let us understand about the bitwise operators. First, we'll understand AND. Bit is 1 only if both bits are 1. Correct? Same like logical operator. Both are true, then true. Similarly, both are 1, then 1, else 0. So if I write here A equals to 10, and in binary it is nothing but 1010. B equals to 4, in binary it is nothing but 0100. Correct? if I perform here print A and B, this particular AND is nothing but bitwise operator, is a bit AND. So if I write here, I'm going to get 0. Why I'm getting 0? Basically 1 0 1 0, and this is nothing but 0 1 0 0. If I try to do here bitwise AND, so what I will get basically? So here 0 0 is nothing but 0, then 1 0 is nothing but 0. Again, 0 1 is nothing but 0, and 1 0 is nothing but 0. So I'm going to get 0 0 0 0. Now this is a binary number which will be converted to integer, and I will get the answer as 0. So I hope you understood about this bitwise AND. Similarly, if I write here print A or B, this is nothing but a bitwise OR. Okay, this is nothing but bitwise OR. What is bitwise OR? If bit is 1. If either bit is 1, means any of the two bits is 1, then the result is 1 itself. So here 0 0 will be 0, 1 0 will be 1, 0 1 will be 1, 1 0 will be 1. So my binary number will be 1 1 1 0, and the equivalent of the decimal will be 14. Okay. Similarly, now let's see about the XOR. XOR means bit is 1 if bits are different. Basically, it means for 1 0 it is 1, for 0 1 it is 1, but for 0 0 it is 0, and for 1 1 also it is 0. If the bits are different, then it is 1. If the bits are same, then it is 0. Okay, so in this case 0 0 bits are same, so it is 0. 1 0 1, 0 1 1 1 0 1. So answer will be nothing but 1 1 1 0, that is 14. So if I write here XOR, how to denote XOR? Print A cap B, that is XOR. A 14. Similarly, what is NOT based? NOT is nothing but flips or bits, and the result is nothing but result is equal to minus n plus 1. Basically, this is nothing but 2's complement. I hope you know what is 2's complement. If you don't know, I will tell you about that also. So let's say I want to print not A. For that, we have this symbol, not and A. A is nothing but 10. So 2's complement of 10 is minus 11. That is 10 plus 1 is 11 minus 11. Similarly, if I write print not 34, so I will get minus 35. Okay. So what is 2's complement? Let's see here. I'm going to share one screen. Okay. So 2's complement is a way to represent the signed integers in binary. It allows both positive and negative numbers and simplifies arithmetic subtractions. So how to find 2's complement? So if you have any binary number, okay, first we invert all the bits. 0 is then it will convert to 1. If it is 1, it will convert to 1. And then we add 1 to the inverted binary. So basically, if I want to find 2's complement of plus 5, so this is plus 5. First, I will invert all the bits here. If it is 1, it will be 0, 0, it will be 1, 1, 0, and all the 0 will become 1. And then we'll add 1 to it. 1 plus 0, 1. Like this. So if I add these all bits, I will get one binary number. This is nothing but a 2's complement. I hope you understood about a 2's complement. Next thing about the left shift and right shift. So before moving to these two operators, left shift and right shift, let us understand what is left shift and right shift. So if I have a binary number, let's say 5. So if I do something like this, 5 left shift 1. So all the bits will get shifted by one place towards the left. So here 1 will be shifted to left like this. 0 will be shifted like this. 1 will be shifted like this. And so on other numbers also. And whatever here digit is there, it will be padded with the 0. Okay. So if I left shift this, originally the number was 5. Now I got 10. Okay. So left shift by n is equivalent to multiplying by 2 raised to n. So here I am left shifted by 1. So basically this will be nothing but 5 multiplied by 2 raised to n, that is 2 raised to 1, because I have left shifted by 1. So 5 into 2 is nothing but 10. So result is 10. Similarly, what is right shift? Right shift means we'll shift towards the right. correct? So this 0 will be shifted here, this 0 will be shifted here, this 0 will be shifted here, this 1 will be shifted here, 0 will be shifted here. So here in this case, the result is 2. Basically, right shift is equivalent to dividing by 2 raised to 1. So it was 5. 5 divided by 2 raised to 1. That is nothing but, answer is nothing but, quotient is nothing but 2. Correct? Quotient here will get 2, result is 2. So I hope you understood about the left shift and the right shift. Now let us execute this left shift and right shift in Jupyter. Let's say my number is 1010, that is 10. So A equals to 10. That is nothing but 1010. Now if I left shift it, left shift. So print A, for left shift we have this symbol by 1. Left shift by 1 bit. So this is nothing but equivalent to writing like this. That particular number 10 will be get multiplied by 2 raised to 1. That is nothing but 10 into 2. That is equal to 20. So I will get the answer as 20. Correct? Similarly, if I right shift it, print A, right shift to 1. This is nothing but 10 divided by 2 raised to 1. This is nothing but 10 divided by 2. That is nothing but I'm going to get answer as 5. Answer as 5. So I hope you understood about a left shift and right shift. What is a left shift? It is equivalent to multiplying that number into 2 raised to n, and right shift divided by number 2 raised to n. Okay. What is the practical use of bitwise operator? Okay. Let's say the first use here. Check if number is even or odd. Okay. And this particular method is faster than modulo division. This particular bitwise operator we will be using here to check even and odd, it is much faster than bitwise operator. If I write something like this, n is equal to 17. If n and 1, then print odd basically. Let's say take a simple example. Let's say n is equals to 10. N is equals to 10. That means the binary equivalent is 1010. And I am doing bitwise and with 1. 1 is nothing but 0001. If I perform the bitwise and, what answer I am going to get? If I perform the bitwise and, what answer I am going to get? 10 is nothing but 0, 00 is 0, 100, 01 is 0. So all 0 I am going to get. Let's try to execute this for odd number. Let's say n equals to 11. So for n equals to 11, this is the 1011, correct? If I do and bitwise and with 0001, what is the result here? I'm getting 10 is 0, 000, 100, and 11 is anyone 1. So basically, if it is an even number, I'm getting here 0. Basically, if it is an odd number, then I'm getting 1. So last bit is 1. So in odd, the last bit is 1. And basically, if the last bit is 1, it means the number is 1 and 1 means nothing but true. So that means if this condition is true, print the odd. Else, else print even. Actually, this is will be string, else print even. So I hope you understood this. If I execute this now, so I will get 10 is an even. Similarly, 15 is odd. 106 even, and so on. So this is much faster than modulo division, bitwise operation. Okay, now the most important concept that we will study now is about the operator precedence. Basically, if I have combination of operators in an expression, how it will get executed, what is the precedent, which operator has the highest priority, which has the lowest priority. So this we will see now. You must have studied about the Modulus rule in the school math, right? But in Python, we have other operators also. So what is the highest priority? It is of course the parentheses or brackets, and the associativity is from left to right. Exponent, the associativity is from right to left. What things you have to remember here? Associativity of exponent, that is right to left. Similarly, if I have unary plus minus bitwise not, plus x, minus x, and not x. That is bitwise not. This is the third highest priority. That is also associativity right to left. Then we have multiplication, division, modulus, associative left to right. That is by default. Then we have addition, subtraction. Then we have bitwise, all the bitwise operators except the bitwise not, bitwise shift, bitwise and, XOR, or all this we have further. Then we have all the comparisons and membership and identity operators. And then all the logical operators at the last. The lowest priority is about the logical or. Okay. So I hope you understood about this particular operator precedence. Or this thing you have to keep in mind. Now let us solve some questions related to operator precedence. Okay. So starting from the basics, let's say print 10 plus 5 into 2. Now how this will be evaluated? First multiplication will be evaluated 5 into 2 10 and then addition will take place. Okay, if I write here 5 into 2 10, 10 plus 10 20. What if I want this particular to be evaluated first? Then I want to provide your brackets. Basically, I will provide brackets 10 plus 5 and first bracket will execute into 2. Now I will get the answer as 30. I will get the answer as 30. What is the error? Print. Okay, 30. Okay, I hope you understood about this. Now let us understand about this. Star star before unary minus. That is exponent before unary minus. If I write print minus 2, the whole raised to 2, what output I'm going to get? Minus 4. I'm not going to get the output as 4. So first what will be executed? So first it will do like this. 2 raised to 2, that is 4, and then minus will be executed. If I write something like this, print, now I'm printing minus 2 in brackets and then raised to 2. Okay. Now I will get answer as positive 4. Basically, negative square is always positive, we know. Minus 2 square is 4. But here I am not providing the bracket, that's why it is giving me minus 4. In this case, exponent is working first and then negative, unary minus is working. If I want unary minus to work first, I need to provide a brackets here, minus 2 brackets. So first, what will happen? Bracket will get executed, minus 2, and the whole raised to 2, that will be mine, plus 4, sorry. I hope you understood this. Okay. Now let's have some example ready to mix arithmetic. Let's say print 10 floor divided by 3 plus 5 module divided by 3. How it will execute? I'm getting the answer as 5, but how it will execute this? First floor division will work, then modulo division will work, and then plus operator will work. So first floor division. So 10 floor 3. What is the answer here? 3. Correct? Quotient, that is 3. Then now this is something like this now. 3 plus 5 modulo divided by 3. Now this 5 modulo divided by 3 will work. That is the second operator precedence, second highest is modulo. So now it will work 5 modulo divided by 3. So what is the remainder we get? 2. And then 3 plus 2 will work, that will be 5. So our answer is nothing but 5. So I hope you understood how it is working. Okay, next, let's see about comparison versus logical operator. Okay, let's say print true or false, false, and false. Okay, so here we have or and also, correct? So basically, first and will work and or will work later because or has the lowest priority than and. So first and will work. False and false, false. True or false, true. So I will get answer as true. Okay. If I print like this, print not true, or false. Not true or false. So basically, what is the output I'm going to get? False. So basically, first not will run. Not true is nothing but false. False or false, false. Like this. Okay. Now, Let's say x is equals to, I'm using like this, true or false and not false. So what is the answer I'm going to get? Print x, true. So in this is a bracket. So true or false will execute first, it will give me true. And not false will execute later, and it will give me true. So true and true will give me true. So answer is true. So I hope you understood about the operator precedence. Can practice more questions on operator precedence. So next operator is nothing but the ternary operator. So if you have studied C language, there you must have come across this particular operator, that is ternary operator. And the symbol for the or notation for that we use something like this. Condition, question mark, one condition, colon, something like this. But in Python, we don't use something like this. So for in Python, the syntax is basically like this. Result is equal to value if true, if condition, else value if false. Let us try to understand this with the help of example. Okay. First, I'm writing a regular if-else statement. Let's say if age is equal to, let's say 20, if age is greater than equal to 18, status is equal to adult. Okay. Else I'm writing status is equal to minor. Okay. And then I'm going to print the status. This is nothing but my normal if-else statement. If age is greater than 18, print this, else print this. So I'm going to get your adult because age is greater than 18. What if I want to use ternary operator here? Now using ternary version or operator, what we can write here directly, status is equals to adult. That is nothing but value if true. So here I am giving one value if my condition is true. So here I want to provide the condition, true condition. If my age is greater than equal to 18, else if my condition is false, then minor, then it is minor. So this is how we can write. So here if I try to print the status, I will change the value of age also. Let's say age is now 12. So I will get minor. So it will check. This particular thing is nothing but true value if condition, else value if condition is false, like this. So this is nothing but ternary operator how we can use it. More examples if you want. Let's say x is equal to 10. Label is equal to, let's say, even. Label is even. When I will give the label even, if x modulo divided by 2 equal to 0, else my label will be odd. Like this. And then print the label. Print label. I will get answer as even. So I hope you understood about a ternary operator also. So when we use ternary, whenever our logic is simple, only one particular condition is there. If else, if this condition is true, then this, else this, like this. Okay. So I hope you understood about today's video. So let us have some glance what we have discussed today. We discussed about what is operator and expression. We discussed about different arithmetic operators, assignment operators, comparison operators, logical operators. We also discussed about the membership operators, identity operators. Then we also discussed about the bitwise operators. Then what is two's complement, left shift, right shift, understood the difference between this, and what is the equivalent of left shift and right shift. Then lastly, we discuss about the operator precedence and the ternary operator. Okay. So this was all about today's video. If you find this video helpful and interesting, do like, share, and subscribe the channel for more such videos. Thank you so much for watching.